All right. We are going to continue the 2016 AP Calculus AB practice exam, all right? And we are going to do multiple choice questions, number 21 through 28. This will finish the multiple choice segment of section 1, part A, where we do not get a calculator. No. Follow me, because when I started to do the other multiple choice questions and post those videos, and then the 6 short answer problems are each an individual video, by following me, you'll get notifications of when I post them. All right, and like this, because that helps me. In the long haul, it helps me if you like these videos. Let's get started, because these last few that do not use a calculator can be a little bit rigorous. But again, without the calculator, the algebra is easy. It's just the setup and work through that gets lengthy. Question 21 says, the table above gives selected values for a twice differentiable function f. Which of the following must be true? So just to remind you, if it is twice differentiable, we could take the derivative twice everywhere, and it's also continuous, okay? So which of the following must be true? So any circumstance, we're picking an option that'll be true no matter what. Not true sometimes, but true all the time. A says f has no critical points in the interval from -1 to 5. All right, well, -1 is where we start, 5 is where we end. Okay, I look at that and I see to myself that that function is constantly increasing. Okay, it's constantly increasing. That's an increasing line that has no critical points. The critical point is where the first derivative is 0 or undefined. A 0 is a horizontal tangent line. Okay, so I can go like this, go up, and I can do that. I can create a situation where that is true. Okay, or corner, you know, it's undefined here. That's also a critical point that increases. But it doesn't have to be true all the time, because I can create this, which would make choice A not be one of those things that must be true no matter what we do. Choice B, if the first derivative of x, f prime of x, is 8 for some value of x in this interval, okay, again, from -1 to 5, this screams mean value theorem, which says my derivative at some point has to equal the average slope between the 2 points, okay? Just change in y over change in x, okay? So this has to be true if it is continuous and differentiable in the interval, which it is. This has to be true. So let's figure out what this is. Okay, we'll call this x1 and y1. y1 is this. x2 and y2, which is this. We have 18 minus -30 all over 5 minus a -1. All right? That is 48 over 6, and that is 8. Okay, so this right here is the same thing as saying 8. My first derivative is equal to 8. If my function is continuous and differentiable, which it is, that has to be true. So my choice, B, must be true no matter how I draw this graph. It must be true. Mean value theorem. 22. A particle moves along the x-axis so that at time t is greater than or equal to 0. The acceleration of the particle, a of t, is 15 square root of t. The position of the particle is 10 at time 0, and the position of the particle is 20 at time 1. What is the velocity at time 0? Okay, position, I'm going to call P. Velocity, acceleration. These are one derivative away. Those are d's for derivative, which means if I have acceleration, in order to get velocity, I go backward and I have to integrate. Okay? So the first thing I'm going to do is I'm going to integrate acceleration, which is 15 square root of t dt. Okay? That will give me the equation of velocity, because they're asking you, what is the velocity of the particle at time 0? So I'm trying to find v of 0. That's ultimately what I'm trying to figure out. But I need the equation for velocity first. All right, well, let's maneuver this a little bit to massage it. I'm going to bring the 15 on the outside. It's a constant. Integrate. I love exponents. So I'm going to make the square root into an exponent of 1/2. Okay, now this is a lot easier to integrate. All right, so I'm going to I have my 15 on the outside. My 1/2, okay, I've got to do this in the opposite order that I take the power rule. I'm going to add 1 to this first, so it's going to become t to the 3/2. And then I divide by 3/2. Dividing by 3/2 is the same thing as multiplying by the reciprocal 2/3. Okay? Plus c. Why do I say plus c? There are no bounds here. All right? So let's clean up what we have. 3 goes into 15 5 times. 5 times 2t is 10t to the 3/2 plus c. This is velocity. Except I don't know what that c is. This is the million-dollar question right here. Like, I need a number here for c. All right? And let's just call it what it is. I'm trying to find v of 0, aren't I? That means when I put a 0 in for this t, I'm going to put a 0 in for this t, which means this will go bye-bye. And my answer is going to ultimately be whatever c is. But let's not get too far ahead of ourselves. Let's figure out what c is first. We'll plug the 0 in afterward and go from there. How can I figure out what c is? Well, the only thing they give me is to say position equals 10 at time 0, and position is 20 at time 1. So give me p of 0 is 10, and p of 1 is 20. It looks like I need the position formula to use those. All right? So again, I have velocity. I've got to integrate velocity to get position. So let's integrate. We have 10t to the 3/2 plus some constant dt. All right. Oakley dokley doodly. 10, again, I'm going to bring that on the outside. 10. Let's just do this. Here. I've got to add 1 to the exponent, which means it's t to the 5/2. And then I divide by 5/2, which is the same as multiplying by the reciprocal 2/5. Okay? Plus any constant. If I was integrating 2, it would be 2t. I just bring the variable back in. I don't know what constant it is, but whatever it is, I just bring the variable back in. Guess what? There are still no bounds. I still need to add some constant. I'll call this constant k. All right? This is position. Let's clean up what we can and get rid of this. Okay. We're doing good. You're hanging in there. This is a rigorous problem. All right? 5 goes into 10 twice. 2 times 2 is 4t to the 5/2 plus ct plus k. Okay, that equals my position. Let's start with this. At time 0, my position is 10. So I'm going to make this 10 when all my t's are 0. Okay? 10 equals, well, 4 times 0 to the 5/2. I should really rewrite that. 4 times 0 to the 5/2 plus c times my t, which is 0, plus k. All right, let me rewrite that. Okay, anything times 0, bye-bye. Anything times 0, bye-bye. And now I've got k equals 10. All right, that's cool. That's cool. It looks like I found this value here. So let's plug that in for k. Okay, I found the constant that goes with position, but not the one that's going to eventually go with velocity. That's the one I need. So I've got position equals 4t to the 5/2 plus ct plus my k, which we just said is 10. I'm so glad they gave me 2 coordinates. I mean, I suppose I can use this one again, but they gave me 2, so I'm going to use 2. All right? At time 1, p should be 20. So my output should be 20 at time 1. So 1 to the 5/2 plus c times 1 plus 10. All right, so I've got 20 equals 4 times 1 basically is 4, plus c times 1 is c, plus 10. All right, good, very doable. Minus 10 minus 4. C equals minus 10, which gives me 10, minus 4, which gives me 6. I now have my c variable. Follow me here. That goes right there. Again, they're looking for v of 0. We now have the full equation for v. Okay? V of t is 10t to the 3/2 plus 6, because that's my c value. They want to know v of 0. 10 times 0, even if it's to the 3/2, goes bye-bye. V of 0 is 6. That was a lot of work. The algebra was easy. Take your time, go through there, and make sure you do it right, because it is very, very doable if you set it up right and go that way. Trust yourself. 23. Which of the following is the solution to the differential equations, I should say, dy dx equals 2xy over x squared plus 1, whose graph contains the point 0, 1. Notice my answers. Okay, first let's look at our answers. Let's go here, let's go here, that's great. Okay? Solution to the differential equation, that tells me I have separable differential equations. I'm going to get my y on the side with dy, and I'm going to get all my x's on the side with dx, then integrate. But none of these answers have a plus c in it. When I integrate, I don't have bounds. I'm going to need plus c, unless they give me an initial condition where I can solve for c. When x is 0, y is 1. Okay? Let's start this bad boy. I will rewrite this, even though I hate rewriting, but it's for a good cause. It's for you learning. 2xy over x squared plus 1. All right. Let's multiply this side by 1 over y. This goes bye-bye with this. 1 over y. What I do to one side, I have to do to the other side. Let's multiply the left side by dx. Bye-bye, bye-bye. And I multiply this side by dx. So what I have now is 1 over y dy equals 2x over x squared plus 1 dx. I can now integrate both these bad boys. Okay? The integration for the left side is easy. It's a rule. The ln of y plus c. No bounds. I need to have a plus c. Equals. If this doesn't jump out to you at this point, you better study this and get this. U sub. How do I know I'm going to use U sub? Because if I look at the bottom, x squared plus 1, the derivative of the bottom is 2x. When I see the derivative in with the equation, meaning x squared plus 1 is there, and the derivative of x squared plus 1, 2x, is there, that is a classic classic u sub. So I'm going to make u equal to x squared plus 1. And I'm going to say du is 2x dx. Remember, I just take the derivative of this. Okay? Now, 2x dx is completely going to go bye-bye because I'm going to put du in for that. Okay? And then x squared plus 1, I'm going to turn that into u. So I'm now going to integrate 1 over u du. That was exactly like this was. We should know that. That's the ln of u plus c. That should equal the ln of y plus c. Keep in mind that these constants are two different constants. I'm just going to put a little sub 1 and sub 2. They might be the same, who knows? But there are literally an infinite amount of constants. And the fact that they might be the same are real slim. But even if they're the same and you get 0 when they cancel, 0 is still a constant. You can still represent that with c. Okay? All right, let's get this c over. Let's subtract one of these. Boop. And I now have the ln of y equals the ln of u. I don't have bounds that I can convert and just do the algebra to finish this. I need to bring this back in for u. Okay, so I'm going to bring that back in right now. That's x squared plus 1 plus some constant. Okay, I can put c3 there if I want, but if I have a constant and I combine it with another constant, guess what? The result is a constant. All right, so we need to get y alone. Look at all of our answers. They're all y equals. Okay, so I am going to base e. Some mathematicians don't like this, but it works. Y equals, this whole thing is the exponent. What is my rule when I add exponents? If I have e squared times e to the 5th, that is when I add exponents. Okay, so I had to, in order to get this exponent where I'm adding the exponents, I had to multiply similar e's here, meaning I take e to the ln of x squared plus 1 times e to the c. And that's how I ended up adding them up here. Okay? Now, here's the beautiful part. Watch the magic happen. If you've made it this far, that's pretty good. Okay? E and ln cancel. So I've got x squared plus 1. E is a constant. If I have a constant raised to another constant, that will still result in a constant times some constant c equals y. None of my answers have a c in it. Why is that? Because they give me an initial condition specifically where I can solve for c. When x is 1, when x is 0, y is 1. So I'm just going to substitute in a 1 for y and a 0 for x and solve for c. Let's do that right here. 1 equals 0 plus 1 is 1 times c, so 1 equals c. All right, I need an equation for y. This is where y was alone before we knew what c is. Okay, now we just figured out what c was. So all I'm going to do at this point is just substitute this back in for c here. So y equals x squared plus 1 times 1, because that's what c was, 1. X squared plus 1 times 1 is just x squared plus 1. This satisfies the initial condition of 0, 1 with the differentiable equation that they gave us. Oh my goodness. Here's the answer. Whoo! Some brain work going on. 24 says, sand is deposited into a pile with a circular base. The volume of that pile is given by V equals r cubed divided by 3, where r is the radius of the base in feet. The circumference of the base is increasing at a constant rate of 5 pi feet per hour. When the circumference of the base is 8 pi feet, What is the rate of change of volume of the pile in cubic feet per hour? My goodness, a related rates problem. Related rates is a lot like implicit differentiation. For implicit differentiation, anytime I took the derivative of the y, I would have to write dy dx right next to it. For related rates, anytime I take the derivative of a variable, maybe radius, volume, whatever, I need to write dr dt next to it, or dv dt. All right, let's break down what this is asking us and what they gave us. All right, so you know I love the calligraphy pen. I ain't ever changing from the calligraphy pen. We'll go back to orange. Here's volume. Volume is this. That's probably going to come in handy. All right, where r is the radius in feet. The circumference of the base. The circumference of the base is increasing. That tells me it's a rate. Circumference rate. Oh, and it says rate here of 5 pi. So dc, with respect to time, is 5 pi. Okay? When the circumference of the base is 8 pi feet, what is, and here it is, here's the money shot. What's the rate of change of the volume? So I need to find dv dt when the circumference is 8 pi. When circumference is 8 pi. All right, we have everything we need. Let's move forward. Well, first, if I got to find this, why don't I just take the derivative of velocity and actually get that equation? And then we'll see what else we need to solve that. Okay? If velocity is r cubed over 3, all right, then dv dt, the rate of change of volume, is 3 comes down. I subtract 1 from that, over 3, okay, times dr dt. All right. We can simplify this further, and the 3's cancel. So it's r squared dr dt. The question is, I need the radius, and I need dr dt. So I need to find a value for r, and I need to find the rate of change of r. All right? So let's start and see if we can't figure this out. All right, so, okay. The change in rate of circumference is 5 pi. Let's do that first. Circumference is pi times diameter. But you best know that diameter is 2 times the radius. So I'm going to say it is 2 times the radius. I'm going to just mash the pi in there. Okay, that's circumference. If I take the derivative of circumference and make that equal to 5 pi, dc dt is, these are constants, they'll stay the same, 2 pi. The derivative of r is really 1 times dr dt. Look at that. The change in rate of the circumference is 5 pi, so 5 pi equals 2 pi. Anything times 1 is just itself. dr dt. There we go. We can find dr dt right now because it's our only unknown. So let's divide both sides by 2 pi. Divide this by 2 pi. The pi's go bye-bye. So 5 halves. That's my rate of change of my radius. Okay? So that is going to be... There you go. That's going to go in for dr dt. In fact, let's plug that in now. We got dv dt equals, I don't know what r is yet, but I do have dr dt, that's 5 halves. All right. Radius. All right, well, I used this. Okay, I'm solving for this. I bet that can help me find my radius. So circumference is 2 pi r. Circumference is 2 pi r. Circumference, okay, then with the radius, the moment my circumference is 8 pi. Oh, be still my heart. Let's divide both sides by 2 pi. Gone. My radius is 4. 4. So now I have my radius. Okay, this, boom, it's going right there. Radius is 4. I'm trying to solve this. So let's do our math, okay? 4 squared is 16 times 5 halves. 2 goes into 16 8 times. So 8 times 5 is 40. It was a lot of work to get to our answer, which, by the way, it's 40. It's not 40 pi. Those pi's all canceled out. Okay? Those pi's all canceled out. Don't fall for that. Don't see the 40 pi and automatically circle it. Okay? Again, we had to stage 3 different things. The rate of change for velocity, the rate of change for circumference, and find the radius of a circumference at a certain point. All very easy algebra, but it's more than one thing. We're getting closer to the end of these multiple choice problems, and you will get problems just like this. The last 2 or 3 have been, pretty burdensome compared to the beginning ones. 25. If you're looking at this and you're saying to yourself, this is another one that's going to be difficult. It is not. It's very easy. And let me explain why. If you noticed one thing about this, this becomes very, very easy. The definition of a derivative using limits is the limit as h goes to 0 of f of x plus h minus f of x all over h. Okay? This is how we used to do the derivative. If I had x squared and I did this whole funky thing to it, I should end up with 2x. Because we could just use the power rule. But before the power rule, we had to use that definition of a derivative. Now, if I look closely into my definition of a derivative right here, my original function goes right here. Okay? So that is where I would put x squared. Okay? When I'm teaching my kids this in class, and I see the x squared, yep. Okay? And I see the x squared in that position, I automatically know, well, it's just going to be 2x. Because I'm just taking the derivative of whatever's right here. Let's look at the problem they gave us. That was e to the negative x at x equaling 1. So they just threw a 1 in for the x here. So all you got to know is how to take the derivative of this and then plug a 1 in. That's it. If you can make that connection, that's cake. The derivative of e to the negative x, I always start by rewriting this, is e to the negative x times the derivative of the exponent. The derivative of negative x is negative 1. So I end up with negative e to the negative x. But I want that. Okay, notice none of my answers have an x because we want it where x is 1. So we got negative e to the negative 1. Well, anytime we have a negative exponent, we need to flip it. Let's not forget, there's still a 1 here. So I'm going to take this and flip it. So I have negative 1 on top, e, and now I have a positive 1 here. Or I can rewrite that as negative 1 over just e. And that choice is choice B. So if you know what you're looking for, if I didn't have to explain to you the definition of a derivative, if I did not have to explain the definition of a derivative, and just went right to purple here, that problem takes all of 8 seconds. Number 26, let f be the function given by f of x equals x cubed plus 5x. for what value of x in the closed interval from 1 to 3 does the instantaneous rate of change of f equal the average rate of change on that interval? Just like we started this out, when the instantaneous rate of change equals the average rate of change, that's the mean value theorem. Okay, they're asking what value of x makes that true. We did that for problem 21 in this video. Okay, so in case you forgot, that is not a coordinate. That's from when the first x value of 1 until my second x value of 3. Okay, so what I want is I want to take my derivative and set it equal to change in y over change in x. In this case, 3 minus 1 goes on the bottom, and I find the y value of 3 and subtract the y value at 1. Okay, now keep in mind, no calculator. This is very, very doable. Okay, notice there's a square root symbol in all my answers, so I'm probably going to have a square root in my work here. All right, if I throw a 3 in here, 3 cubed is 27, plus 3 times 5 is 15, minus, now if I throw a 1 in here, that's 1, plus throwing a 1 in here, 5 times 1 is 5, all over 3 minus 1 is 2. All right, let's clean this up a bit. 27 and 15, well, that's 42, minus 6 divided by 2. We got 36 divided by 2. Looks like that's 18. That is my change in y over change in x. All right, okay. My derivative has to equal this. The derivative of x cubed plus 5x is 3x squared plus 5. That should equal 18. Okay, where does that happen? I only have one x variable. Don't think you got to bring the 18 over and try and factor. Just opposite PEMDAS. Strip everything away from the x. Let's start by subtracting 5. Subtract 5. 3x squared equals, what do we call that, 13? Divided by 3, divided by 3. Bam! X squared equals 13 over 3. I need to get the x alone. Opposite math. This happens at the square root of 13 over 3. Now, if you're watching this video, you might be saying to yourself, Mister, anytime I undo a square root, I'm supposed to put plus or minus. You are. None of these answers are plus or minus. You came up with 13 over 3, which is fine. The square root of 13 minus 3 is between my interval 1 and 3. Okay? So the positive version of this is in between 1 and 3, the interval they gave us. This one is not. Obviously, that's a negative value. That's less than 1. So I don't want the negative version here. Don't want the negative version here. Just the positive version, which is choice B. 2 more problems. Goodness, these are some good problems. So it's a good problems. I got someone in pre-calc taking the test here, and they're looking like, wow, it's nuts. Anyways, 27. If e raised to the xy minus y squared equals e minus 4, then at x equals 1/2 and y equals 2, what's the derivative? Oh my goodness. All right, we talked about implicit differentiation when we did problem 24, when we did the related rates. This is implicit differentiation. We can't get this y equals, so we're going to just take the derivative right down the line. And anytime we take the derivative of a y, we need to write dy dx next to it. Okay. All right, let's go. We will do this in different colors. Anytime I take the derivative of e, I automatically start by rewriting it. Times the derivative of the exponent. That's the product rule. That is the first times the derivative of the second. Okay, the first being x, the second being y. So dy dx. First times the derivative of the second plus the second which is y, times the derivative of the first. The derivative of the first, x, is just 1. All right, that's just the first term. Minus, okay, minus the derivative of y squared. I handle it just like it's an x. It would be 2y. But since we're taking the derivative of y, dy dx equals, guess what? This is a nice break because both of those are constants. There is no variable here. The derivative of a constant is 0. All right. So let's smooth this out a little bit, shall we? All right. The first thing I'm going to do is distribute this into here. We want to get rid of these parentheses. So e to the x, y times x times dy dx plus, okay, this is just y. So we'll just call that y times e to the xy, okay, minus, all right, 2y dy dx equals 0. I didn't do anything here or here. I need to keep everything with a dy dx on one side so I can factor it out. Anything without a dy dx needs to go to the other side. All right? So let's do that. Here. Let's subtract y e to the xy. Subtract y e to the xy. Bye-bye. E to the xy, x dy dx minus 2y dy dx equals negative y e to the x y. Okay, you're doing good. Don't freak out yet. We're doing good. I got to factor this and this out. GCF. dy dx equals, we'll put the x in front, x e to the xy minus 2y, all right, equals negative y e to the xy. All right, I said equals there. I should be multiplying it. We are almost done. I'm going to divide both sides by this, okay, to get rid of it on the left side. What I do to one side, I have to do to the other side. Okay, dy dx now equals this thing right here. But they want an exact number. I mean, that was enough to make me have to sit down and take a break. But they want this when x is 1/2 and y is 2. Oh boy, let's go down here. That's x equals 1/2 and y equals 2. Let's just plug in the number, shall we? Y is 2, so we got negative 2. E, x is 1/2 and y is 2. Okay, all over. X is 1/2, e to the x, which is 1/2, and y is 2, minus 2 times y, which is 2. My goodness. All right, 1/2 times 2 is 1. That's just e to the 1. Same thing here. That's just e to the 1. All right? I'm going to have to get rid of that fraction on the bottom. Shame on you. So what do I end up with? I end up with negative 2e over 1/2 e minus 2 times 2 is 4. All right. They want us to get rid of this 1/2 because I don't see any answers, or my fraction has another fraction in the bottom. So let's multiply everything times 2. Multiply the top times 2 and the complete bottom times 2. That's negative 4e all over. That goes by 1/2 times 2, and I just end up with e. Minus 2 times 4 is 8. All right. Let's take a look at these. You might not see anything up top that has negative 4 over e minus 8. we ended up with -4 over e minus 8. This looks good. Guess what they did? They multiply this whole thing times -1, the top and bottom. So now you got 4, because I flipped the sign, and minus e and positive 8. I flipped the sign on everything here. And they rewrote the bottom. They put the 8, positive 8 first, minus e. So they multiplied the top and bottom by -1 to get this. And then they gave you this. Let me tell you what, if you got that problem, that's legit. That is legit. Last one. Man, we're already 40 minutes in. These were tough, very lengthy. Right, number 28. Let f be the function defined by f of x equals x cubed plus x squared plus x. Let g of x be the inverse of f of x. Oh, I love inverse problems, especially derivatives. This is going to jump right out to me, all right? Anytime I see a g of x, I'm going to rewrite it as f prime of x, okay? Where g of 3 equals 1. So that's the same thing if g is f inverse. I don't know if I said f prime, but anytime I see a g, I'm going to write it as f inverse. So that's the same thing as this, because g is the same thing as the inverse, all right? What is the value of g prime of 3? Again, if they're asking for g prime, that's like the inverse of f prime of 3, okay? Because this tells me it's the same thing. In order to find the derivative of the inverse, it's 1 over the derivative of the inverse at that value of x, all right? And these actually are a lot easier to do if you just do them step by step. It is 1 over the derivative of the inverse of that value of x. Now, we already have this. That was given to us right here, because g is the same thing as f inverse. So the inverse of f at 3 is 1. So this right here is like saying 1. 1 over the derivative of f at 1. And that's the hardest part of these whole problems. Why? Let's just take the derivative of f. Okay, the derivative of f is 3x squared plus 2x plus 1. I want that at x equals 1. And that's going to go in for this bottom right here, the denominator. So f prime of 1 is 3 times 1 squared, which is 3, plus 2 times 1, which is 2. F prime of 1 is 6. 1 over 6. That was a lot of work I did for y'all. But I'm trying to help you. And that's why I do this, and I love doing calculus. I know, I'm sorry, that makes me a math nerd. But like the video, please, that helps me. Follow me, because we need to do the multiple choice section where we do get the calculator next. Then we're going to do all 6 of the short answer problems, and those are all each their own individual videos. So I still have 6 for the short answer and 2 more for multiple choice. Still 8 more videos. Man, and if you want to know when I put them up, the only way to know is if you follow me. Bye-bye.